there is a difference between a unit vector and a unit tensor. That is what we will try to see. See in this particular slide, what you see, I'm utilizing Kronecker delta as a vector here. Here the Kronecker delta as a tensor. So what is the difference? If I uh, use delta ij as a scalar, and I just utilize, or I is equal to 1 to 3 and j is equal to 1 to 3, and if I'm able to write in this way, the components are expanded, I can say this is a unit vector. But so this is a unit vector. But what is a unit tensor? See the if the components of the vector, if the components of the vector are given by the Kronecker delta ij, this is the Kronecker delta ij, then I call this as unit vector. Okay. But the same thing, if I let me, yeah, if I same thing, if I make this as the Kronecker delta ij Kronecker delta. So this is the Kronecker delta. These two components, you can see this. This is the this. So this Kronecker delta is used in the components of a tensor. That means components of the tensor are given. So by the Kronecker delta, how do we write it? Now this is no longer a unit single line, but this should be a double line. So this is unit tensor. So this is sigma I j. This is delta ij. This is a scalar quantity. This should be a scalar quantity, but this is represented as delta I a vector, delta j a vector. See, you can see how this is represented without any lines underneath. Suppose if there are no lines, or you can use the bold letters. This is what is meant. So in overall, if I represent, if I want to say simply unit vector, this is unit vector. I think you are able to get. That means it is represented by the Kronecker delta ij. If I want to say unit tensor, I write this way. This is unit tensor. This is the components of the tensor are given by the Kronecker delta. That is known as unit tensor. See, generally the tensors, when you are using tensors, we represent the dyadic product like this. These are the vectors again. So they are the dyadic products, or you can say unit dyads. Individually, they are unit vectors, and combined together without any multiplication sign, they are called as unit dyads or dyadic products. Right. Some what you call definitions with respect to this dyadic products. Very important here. So this is again I am writing here some definitions with respect to the unit dyads. These are the definitions. So you can see this is Equation 1, this is definition 2, this is definition 3, this is definition 4, definition 5, and definition 6. Of course, unit vectors, the definitions of the unit vectors are helpful in deriving this also. So, as it is, if there is a double dot between two tensors, double dot between two tensors, what do you call it as? The scalar product or double dot product of two tensors. What do you write? It is known as if the double dot operation. The scalar product of two tensors, or we can also call this as double dot product of two tensors. I call it as a scalar product of two tensors. I can also say it is a double dot product, scalar product or a double dot product. So that means if I write this way, what is the first form? First one, I say delta I, delta j. These two are the put together. This is one tensor. Then another tensor, delta L, delta K. Put together another tensor. So scalar product of two tensors. Now it becomes scalar product of two tensors. So scalar product of two tensors, how this can be written? See, I am referring to a scalar product of two tensors. Very simple. I and K are combined like this. Del I dot L K, and the another one is simply del J dot L. Yeah. Let us see the difference. Yeah. So again, you know the dot product of the two unit vectors. So this is del I K. This is del J. So this is an important operation. We will see some scalar product of two tensors, double dot product of two tensors again. Okay. Hope you got the point. In this video, we try to understand what you mean by unit vector, unit tensor in terms of Kronecker delta. When a tensor is written in terms of Kronecker delta, and the components of a tensor are written in terms of the Kronecker delta, we call it as a unit tensor. We have unit vector, unit tensor. Then there are certain identities with respect to the unit dyads. So these are the, with respect to the unit dyads, what are the different definitions here?